This is a quick review of chemical nomenclature, how we name chemicals. First of all, you need to remember there are three what we call types in terms of categorizing compounds. Type 1 is metal to non-metal. Type 2 is transitional metal. Now it can also be any kind of metal that has a varying oxidation number. So transitional metals to non-metals. All right. Type 3, non-metal to non-metal. All right, on a test or an exam, there are only two ways that you're going to be asked anything in terms of nomenclature. It's going to be either write the formula for or write the name of. All right. Type 1 and type 2 follow basically the same rules, okay? And when I say that, I mean you're going to write, if you're asked to write the formula, you always put the symbol of the cation, the first metal, and then the symbol of the non-metal, the anion, all right? And then crisscross each one's oxidation number, all right? It's easy when you're asked to name a type 1 because you just look at the symbol and you just write the name. If it's, Al, you'd say aluminum. Let's say if it were LiCl, lithium chloride, okay? Type 2 is a little different, but basically it's the same. Type 3, you use prefixes, and we'll look at that in a second. So type 3 is basically, it doesn't follow any of the rules of type 1 and 2. So let's do type 1 first. All right, type 1, write the formula for it, okay? So if you're told to write the formula, and let's say I have, we'll start easy, we're writing the formula. We have sodium chloride, all right? All you do is write the symbol for each element. So sodium is Na. Write the charge number +1 because it's in group 1. Chlorine is -1 because it's a halogen. And you crisscross just the number, not the sign, but just the number. If it's a 1, it's understood. You don't have to write the number 1. So it would just simply be NaCl. Okay. All right, let's say we had aluminum chloride. All right, same deal, you're going to put the symbol Al. This time it's +3 because it's in group 3. Chloride is really chlorine. It's a halogen, so it has a -1 charge. Crisscross the charge numbers, AlCl3. All right, and then the last thing is if it had a polyatomic ion, which is more than one element that has its own overall oxidation charge number. All right, if you had ammonium, and let's say it was ammonium sulfate. All right, again, you say, oh, ammonium's not on the periodic table, so it must be a polyatomic ion. What's the formula? NH4. What's its charge? +1. All right, that's the overall charge. Sulfate's SO4 -2. That 2 has to drop down, but it has to apply to the whole ammonium ion. All right, so in that case, you have to put parentheses around it. And then that 1 would drop down, but if it's a 1, it's understood, you don't have to write it, so just be SO4. And that's how we write the formula. All right, when you're asked to write the name, all right, it becomes even easier. So if you're told to write the name of, you're going to put, let's say we have BaCl2. If you're only asked to name it, you don't even have to worry about what subscripts are there. You just say the name of each element or polyatomic ion. So this is barium and this is chloride. So you'd say barium chloride. All right. Let's say it's LiSO3. All right. Well, we know from our polyatomic ion chart, SO3 is sulfite. It has a -2 charge overall. Okay. Lithium is +1. All right. So we don't have to really worry about that, but I'm just reminding you they do have charges. But we just say the name, so it'd be lithium sulfite. Remember, sulfate's SO4, so if it's one less oxygen than sulfate, it would be ITE ending. If you ever see just one single element, all right, the ending is going to be IDE, IDE. All right, so that's how you do type 1. Type 2 nomenclature works the same way for type 2, except there are some elements that have varying oxidation numbers. And I gave the class a chart that has all kinds of elements here that actually have more than one oxidation state. So let's write the formula for it. All right, if you had iron 1 oxide and iron 2 oxide, iron 1 is Fe+1, oxide is oxygen, and that's -2. All right, and if you crisscross the number, you're going to get Fe2O. All right, here it's iron 2, so the Roman numeral indicates the charge. If it's a type 2, it has varying oxidation numbers. So a metal with varying oxidation, this would be an example, Fe+2. Oxygen -2. Now, you would think it'd be Fe2O2, but on types 1 and 2, you have to simplify whenever you can. So the 2's cancel, it's just FeO. All right? So the rule's the same. You're going to write the symbol, the charge, and crisscross them, but this time you have to look at the Roman numeral to get the charge of the cation, the first metal. All right, and that's how you write the formula. Here's probably the trickiest thing of all, is writing the name. If you're asked to write the name, you're going to have to think backwards. All right, so if you're told to write the name of, and let's say it has, let's try another one. Let me do this one. CuO. All right, you just have to remember, and the more you work with these, you'll get used to, bam, automatically recognizing the metals that have varying oxidations. But copper is one of those, so copper is going to need a Roman numeral with it. All right, I know oxygen should have been -2. It's always -2. I don't see anything that dropped down, so I can safely assume, oh, that had to have been +2, and they canceled. So if I think in reverse, it would have been copper 2 oxide. So it's like you almost have to think in a reverse kind of way. That's a little more challenging. All right. If it were copper, let's say it was this scenario, Cu2O. All right. Because remember, copper can exist as copper +2 or copper +1. All right. If it's Cu2O, I know for sure that 2 came from oxygen because it always is -2. I don't see anything down here, so it's understood to be a 1, so that must have been copper 1 oxide. All right, and that's how you do type 2 nomenclature if it involves an ion or metal with varying oxidation numbers. All right, type 3 is the easiest of all. Type 3, it would be 2 nonmetals joined together. All right, so on type 3, all right, and let's say we're doing a formula for it. So if you're asked for the formula, all right, and it's N3O5. All right, you don't have to worry about crisscrossing anything. All you do is look at the subscript and write a prefix for it. All right. If it's one of anything, it's mono. If it's two of anything, it's di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. Okay? If it's one for the first element, you don't ever have to say mono. And the way I remember that is we don't say mono carbon monoxide, we just say carbon monoxide, right? We don't say mono carbon dioxide, we just say carbon dioxide. So if it's the number 1 here, you just say the element, you don't say mono. But it's not a 1, this is a 3, so it's tri-nitrogen, right? And it's penta, but if the part of the penta is going to come together with oxide, the O, you don't want to put two vowels together, drop the first vowel. So you just want to say pentoxide, okay? So tri-nitrogen pentoxide for that one, all right? What if it were, let's just do another one here. What if it were P, and we assume it's a 1, O3, PO3. 2 nonmetals follow the type 3 rule, all right, so we use prefixes. We're going to say phosphorus, all right, and then trioxide. Okay. I'm going to do one more, and then we'll do the name, all right, or the formula, all right. And actually, I was doing the name on there, sorry. I was naming it. All right, let's say we have Si2Cl6, okay? Then we'd say disilicon, and then hexachloride. All right, that's how we do type 3 nomenclature, non-metal to non-metal. All right, the last thing is what if we were asked to write the formula? So we want the formula here. All right, if we had N, or nitrogen, excuse me, I keep wanting to switch them. We have let's say trinitrogen dioxide. All right, tri is 3 and nitrogen is just the symbol N, so it'd be N3, and then oxide's oxygen 2. So N3O2. So you can see how type 3 is pretty easy as long as you know all your prefixes 1 through 10. All right, and then what if you had Si, or silicon, and let me put another, I'll say disilicon, triiodide. Silicon is Si, but I got di here for 2, so I put a 2 there. Triiodide, I put I for iodine, and then tri would be a 3. Right? So just to recap, you got 3 categories, or what we call types, of nomenclature. Type 1 is metal to non-metal. All right, just remember all the metals are to the left of the zigzag line on a periodic table. Type 1 nomenclature is metal to non-metal. Type 2 would be metals that have a varying oxidation number, and most of them are in that transitional area to non-metal. And there you have to use a prefix, Roman numeral to indicate your charge. And then type 3, you use prefixes because it's just non-metal to non-metal, right? And that pretty much wraps it up. Just remember that you'll have available to you a list of polyatomic ions with their charges, and then you'll also, well, that sheet there, you'll also have a list of type 2 metals that have varying oxidations. And that's how we do the naming of chemicals, chemical nomenclature.